Okay. Sorry about the delay. First of all, thanks to everybody for making this possible. I mean, thanks to Karen and Alejandro and Christina and Gustavo and Cynthia and the whole Fundación for bringing me here. It's been really nice. It's a really nice time. I thought I'd show a few of the projects from the last few years. I think this I feel very comfortable in sort of context of these discussions of the sort of big questions around life. And I thought I'd show primarily two different projects today, with one in between. But the first one won an award, I guess, back in 2003, and the last one just won last year. First of all, I should say that all of this work that I'm doing now, that I'm going to show you, it all stems from, it all uses DNA, various types of DNA as a medium. And this work really began in about the year 2000, right before the Human Genome Project was completed. For those of you who don't know, the Human Genome Project is a massive international project to map every single gene on human DNA. There are 30,000 genes approximately, and there are approximately 3 billion base pairs of DNA in the human genome in each one of us. So basically what that so you can imagine in the Human Genome Project, one of the things that had to be done is those 3 billion base pairs needed to be sequenced one at a time. And it was only the brute force of so many different labs working that made this go so quickly. So a lot of this work I'm doing comes out of this new genomics. Just to kind of make it clear, then again, there's 30,000 genes on human chromosomes, and there's 23 chromosomes, and I suppose you probably know some of that stuff. All of this work looks at a lot of the hype around genomics that has really been in place for the last 20 years, such as the idea that we're going to lead to increased cures for terminal diseases. And it kind of turns a lot of this sort of hype on its head. For instance, in terms of medicine, we've actually cured the fewest fatal diseases in the last 25 years since 1875. So it's actually been kind of a bad 25 years for actually curing anything. The medium that I use for all these works, you probably know as something called a DNA fingerprint or a genetic fingerprint. It goes by many names. You can also call this a gel electrophoresis image, because the rectangle that this image is on is actually a piece of gelatin, and those little barcode-like fragments that you see there are actually bits of DNA. I became fascinated with this process as an artistic medium, primarily because it was a way that this kind of minute molecular stuff of DNA could be seen with the naked eye. So it could be actually at a scale we could see it without any kind of magnification. Here's how it works. What you would do is in image A, if you had some DNA chopped into a few different sizes, for instance, this is actually DNA of 2 different sizes, kind of a big one and a little one in terms of lengths. If you were to put that into this pore down here in B, sort of this little opening in the bottom, if you were to put that DNA into there, sort of squirting it in with a small micropipette, and then apply voltage to that gel, the DNA would move slowly toward the positive pole of the gelatin. And that's because DNA has a negative charge, and if you put it into a porous gelatin, it will slowly diffuse through the gelatin toward the positive pole. And most importantly, the little pieces will move faster than the big ones. So that's what we see here in the gel. And if somebody has a quick technical question at any point in this talk, feel free to ask me. So the 3 pieces I'm going to show, the first piece, relative velocity inscription device, was from 2002. The second piece, Latent Figure Protocol, was from 2007, and the third piece, Ocular Revision, just from 2010. And you can kind of look at the categories of what they were meant to address. The first piece from 2002, it began with looking at this phrase that came out in the year 2000 after the completion of the rough draft of the Human Genome Project. And that was when UNESCO scientists said there's no scientific basis for race. And this was an issue. The reason they had to say this was because the Human Genome Project was a return to interest in human genetics not seen since the eugenics movement. The eugenics movement was a human genetics movement from basically 1887 till about end of World War II. The original title for the Human Genome Project was, in fact, neo-eugenics. It was a guy named Robert Shinsheimer that proposed the idea of making this huge database called the Human Genome Project, but at that time he called it neo-eugenics. And it's James Watson, the guy who's the controversial Nobel Prize winner of the double helix, who said, maybe it's a better idea to call this Human Genome Project. Maybe people will get the wrong idea if we call it eugenics. But I was of the distinct impression that while we could say racism is gone, that there's no such thing as race, that racism would not go away. That in fact, racism would move from the skin and it would go molecular. That no longer would we see the black body as prone to promiscuity and such, but rather the very microbodies lying deep within the nucleus of every cell could be demonized. So curiously enough, when I looked at some of the histories of eugenics, one of the major projects that came out was one called Race Crossing in Jamaica, which was published in 1929, and it was an exhaustive study of anthropomorphic differences between blacks, whites, and most importantly, browns, the mixtures, mestizos. Coincidentally, my own family was of Jamaican descent, and likewise had these sort of strange mixtures of black, brown, and white in the family line. So I decided, using this technology of gel electrophoresis, to stage an interesting kind of contest. I invited my family over to dinner, and I also invited a doctor over to dinner, a guy named Dr. Dare. And so I took their blood and I submitted it to a friend, Mary Claire King, who was working at the University of Washington in Seattle, and asked her if she would basically extract from the blood of my family members the genes for skin color, the genes which make certain skin dark. There were about 6 or 8 of them known at the time. And what I wanted to do was to take those genes, take just the DNA from those genes and to stick it into a very custom, really huge DNA fingerprinting gel. And I thought, well, how would contemporary genomicists talk about the difference between themselves and the eugenicists? Well, one of the things they'd say is that when you look at DNA, DNA never changes. But the body, like the body that was known in anthropomorphic studies, could change. If you were a farmer, you would have stronger hands, and if you were a runner, your legs would be in extra fit. Your body could change, but the genes cannot. So I thought, it would be kind of a perverse way of creating a neo-eugenic experiment to try to again look at the difference between blacks, browns, and whites in Jamaica. So what I decided to do was to run a race. So each of the family members' DNA was put into this gelatin in those 4 lanes. And since you know the way that DNA moves toward the positive pole of the gel, I then built this very long DNA fingerprinting gel and basically raced the contestants against each other. You might think of this as sort of a way of looking at genetic fitness, which is a term we hear a lot of now. So what better way to measure genetic fitness than to see who's fastest, whose DNA moves the fastest? This is what it looked like up close. There was a computer below the installation and a camera above, and the camera took pictures every 10 minutes, and then the computer assigned these figures behind the DNA to sort of better show even where that DNA was in the gelatin. Now, when you do a piece like this, you start thinking, am I just being too cynical, to suspect that somehow racism is going to remain consistent? Why not be more optimistic? Then it was curious. This is James Watson, the young James Watson, the same James Watson who claimed the Nobel Prize in 1952 for co-discovering the DNA double helix. Well, James Watson, basically the same month I released this work, gave a talk at UC Berkeley. And he described an experiment that was done by a friend in Arizona. They wanted to see if they could chemically darken the men's skin as a skin cancer protection by injecting melanin into them. Melanin is what's created by our skin color genes. But he observed an unusual side effect. The men developed these sustained and, I guess, very importantly, unprovoked erections. So the minute that he injected these white people with this stuff of blackness, the unbridled sexuality poured forth. And then he went on to say that the melanin injection is even better than Viagra because you don't even have to think about sex. And this is why you have Latin lovers, but you don't have English lovers, just English patients. So what was interesting for me was to see, the most famous DNA man alive today come out with this absolutely what molecular racism is. The idea of implanting upon DNA the cultural stereotypes that the UNESCO scientists were trying to make go away. Anyways, I liked this medium I kept working with. That was 2002. In between, one of the things that happened in between was I became the subject of an FBI investigation over bioterrorism, and it was hard to know exactly how to fight back. But I thought, well, I should investigate the investigators a little bit. So I found this interesting phrase by director of the FBI who said, DNA analysis can now rightly be called DNA fingerprinting because the term invokes in the mind of a jury that we're identifying one individual to the exclusion of all others. Now, interesting, right, that an FBI chief wouldn't be saying, we like the term because it tells you what good science it is. No, he likes the term because it invokes, it creates a kind of picture of infallibility in the mind of a jury, all importantly, not in the mind of a scientist, but in the mind of a jury. And curiously enough, when I looked further, the very man who invented this technology of DNA fingerprinting, who first coined the term, said, if we could call this, he's an Englishman, so he said, if we could call this idiosyncratic southern bloc profiling, nobody would have given a blind bit of notice. Call it DNA fingerprinting, and the penny dropped, meaning that Scotland Yard could not get enough of this. What they loved was this analogy, because DNA, as we've seen, is not like a fingerprint. A fingerprint is a direct imprint. DNA, on the other hand, makes these kind of barcode patterns because someone in a lab chopped it into lots of pieces. So I got thinking, well, I should learn how to do all this. The way that you chop DNA into pieces is you use chemical enzymes. And there are hundreds of them, and each one cuts DNA in different places. Hundreds, and they can be used in combination. Gets a little techie here. Bear with me. So if you imagine each one of these enzymes having an exact location in DNA on one of on these base pairs, that's a combination in which they would cut DNA. Just cut it right at that point. I'll give you a different graphic. This, for instance, is a small organism called a plasmid. It's not even really living. It's man-made. But this is a genetic map. And this genetic map shows where a given enzyme would cut this organism's DNA. This is just its DNA map. You see this one called BAM-H1 and the one below called APO1. This is APO1 right there, and this is BAM-H1 right there. If I were to add those two enzymes to a bunch of this circular DNA that's being shown here, it would cut that DNA in two spots, right? That's how DNA fingerprinting works. You put this stuff into DNA, it cuts it at these known locations, and now you have, in this case, you have two different pieces of DNA, one big and one little. And if you remember this diagram, right, again, if you put a big one and a little one into a hole and apply voltage, then the the little one's going to move the fastest. I thought that knowing how simple this process is, right? The fact that, like, you know, you could know everybody's genome is online. I mean, every organism's genome is online. I can just go, I can find exact base pair sequences for every chromosome of human DNA, every microorganism for the most part. So I thought, what if I could make a program that I could sort of have predict where every possible enzyme could cut DNA, and predict so well that it could basically make recipes for me. I could put an image into that program, like this skull and crossbones, and it could tell me the recipe down here below of the enzymes that I needed to add to make that. Wouldn't that be then the ultimate kind of a counter lab for the FBI? So if the FBI were trying to prove that, you know, the DNA image represents one individual to the exclusion of all others, what if I could show that, you know, from one individual I can make hundreds of different DNA images? So many, in fact, that I can basically make them look like whatever I want. I've got so many to choose from. So, and I thought what was more important is also to do this live, because all of this DNA fingerprinting, it tends to happen in laboratories, mostly for the prosecution, seldom for the defense. There's never usually enough DNA to give to the defense to try any kind of a counter examination. So I wanted to do these things live in front of people. Totally in the open. There I am. I'm squirting DNA into these familiar DNA gels. I've got some camera above them so that I can project the images as they form. And this is one of the early examples. This is from, I guess, a place in Scotland. You can kind of see there's these two icons forming. Copyright was the very first image I made. Copyright ID, and sometimes when I try to get fancy, they're a little harder to tell what they actually are. And when I made the actual prints of the images afterwards, I always thought, well, you know, I should include the recipes on each one, because if you've ever seen a real DNA fingerprint, they never tell you how it was made. I thought I should include the exact recipes, the name of the organism, the time it was made, so that basically anybody can check my work. If this is a counter laboratory and it's almost like the opposite, it's like a scientific proof against the efficacy of DNA for prosecutors, I thought then I should include all my data so that someone can try to refute me. And then I made all these. I guess there's like 6 different images I made of them. So this brings me then to the last piece. I think I have 5 minutes? Okay. The last piece looks again at this term. It's kind of based on this latent figure protocol work. But in this case, I wanted to look more specifically at another metaphor. In this case, the metaphor of DNA, of genetic mapping. Usually genetic mapping means, as in the case of this slide, making maps of DNA. Showing a chromosome of DNA, such as this, and mapping where a given gene on that chromosome is. That's usually a genetic map. I wanted to make a different kind of genetic map. If this genetic map was a map of DNA, I wanted to make maps with DNA. So that DNA would not be the subject, but it would be the medium of the mapping. And I'll tell you why I wanted to do that. And to do it, I thought, well, I should also build a very different kind of DNA rig so I can image the whole world, and I'll try to make it as, rather than as a square, I'll make it as a circle, and I'll see if it works. And it turns out that so I built this thing out of just plexiglass, and it turns out that it worked basically okay. The DNA moved from the outside to the inside in this one. And there's a little picture of it. One of the things that one of the subtexts of this, if the metaphor of the genetic map is something I was trying to take on, the other thing I'm looking at is life. And in thinking about the biology, as the term was coined, 200 years ago, biology is about life, and the cell is the basic unit of life. And the ways through which we tend to understand that object tends to be via vision, via microscopes, telescopes, endoscopes, all these different things that would bring us closer to the organism, and we would understand it through a kind of direct observation primarily. the DNA at this point is quite the contrary, part of a different age. I call it the age of post-biology, because we don't tend to do much understanding of DNA at this point with just the visual image. It tends to be primarily statistical and square, and not about observation, right, or looking deeper, but rather a more kind of computational way of seeing. So ocular revision was also then trying to sort of revision a way of thinking about DNA relative to biology. And for me, it was essential then that I think of DNA as a substance rather than just a code, right? A substance that moved through space and had materiality rather than some kind of a detached code. It was part of the way I thought one could perhaps sort of reunite the molecular biologist with a different way of seeing of the age of biology. So this is the piece that's upstairs, and I'll end with this. I suppose the last thing I should say is that maps also have a lot of meaning, and they're also about kind of ownership and patriarchy in that sense. And I lost my slide. But I wouldn't want to totally omit from the discussion here that this is also taking place sort of as Craig Ventnor is sailing around the world in The Sorcerer II, sampling biological specimens from all over, particularly the most sort of deepest crevices in the ocean floor. Extremophiles he's particularly interested in, bacteria that might have ways of living at higher temperatures, might have ways of enduring high amounts of radioactivity. All these things which are incredibly patentable as the conditions on the Earth become more extreme. So mapping here is also not meant to be some kind of neutral thing. I'm using organisms found throughout the world to make these maps. They're made with by doing tons of experiments to digest and cut bacterial and viral DNA. And I'm trying to use sort of the organisms that span the Earth as well. Thanks.
I'm Phillipe Beesley, and I'm going to be speaking about the work Hylozoic Soil, which is upstairs, and trying to offer a context for it from my own practice and from the larger body of work that I'm involved in along with my collaborators. I speak to you as an architect, and I work in a traditional practice of making public buildings. Alongside that work of making permanent, durable, useful, responsible things, I have been working constantly to try to engender a sense of a relationship with the environment by means of questioning the role of architecture and trying to find a future role for architecture as well. And the talk that I'm going to share with you today tries to offer a sense of relationship with the world, relationship with an environment, and in particular, a kind of psychology that I hope might be an offering to the discussion that Karen and her colleagues have brought together. Centered under the word extimacy, which is a lovely word from Lacan, which doesn't quite mean the inversion of intimacy, but certainly speaks about the sense of a surrounding milieu, a space in which we are all subsumed, which has a pull and which has a consciousness of its own and where the other might reside. And my hope is that this term might be a very useful one to start to probe the possibilities of an expanded physiology, that is, the kind of the anatomy and the structured organisms that might populate the world of a new realm of art and craft that we're all perhaps involved in. Here's some images from the series of works of the Hylozoic series. This one is in Mexico, quite a diffusive cloud, like an artificial forest, or more recent work, which is more weather-like in terms of being diffusive, very delicate filters, which try to populate a space and imbue it with a sense of presence. Just to give a very brief introduction, and then I'll go into the craft of this kind of work later on. The work is structured in multiple layers, which works with very lightweight scaffolds, populated with thickened vesicle and weed-like filters and glands which impart a humidity and a kind of a chemical exchange. Fitted out with meshworks of space sensors and many, many actuators in the thousands now, making cloud-like peristaltic motions, that is, rolling waves of motion that move throughout the piece and impart breathing motions. And then, more recently, is closed with a neometabolic chemistry, a very primitive kind of protocell chemistry. Now, when I describe that and when I show you those layers, the discussion might fall into an instrumental mode of looking at the craft and trying to make things work. And certainly there's a great investment in the technical realm itself. There's a tremendous investment and a love of making, of fabrication. I should say, though, or let me claim, that the spaces that this work makes are a public architecture. If we can see the small hollows and the gathering spaces, perhaps the grotto-like crevices that emerge within this work, and if we see the way people move through it and gather, then let me argue for this as being a contribution to architecture. Certainly not the proud architecture of Tiananmen Square or the Washington Mall or of a great established imperial nature, but rather perhaps a kind of architecture that might serve the beginning of social convergence, of clustering together in village-like forms, of perhaps an intimacy between individuals that grows and that perhaps makes a resilient kind of public, a public of a future. Let me leave that as an assertion, and perhaps I can justify it by sharing some more imagery. To situate this work in a sense of a basic relationship with an environment, and I'm trying to argue for the most primary kind of relationship of an architectural response, of a contribution to the built environment. Perhaps if we thought of a historical sense, we could think of a landscape which is absolutely silent and firm and reliable, perhaps standing on rock which has been stripped by the ice ages of all of its upper turfs, of its limestones, taking it right down to the magma. I'm lucky to live in this kind of landscape, being close to northern Ontario and in Canada. Perhaps you can relate to it in landscapes of your own. This sense of nature being absolute and the world being certain underneath us produces one kind of architectural response, perhaps, in history. If nature is there and reliable, then architecture has a rather lovely sensitive task of spinning a filter around us, perhaps of acting as a mediator, perhaps of sheltering us, of tempering the action of the sun or the wind. In a new age, and a modern age of this last 100 years, a very different project seems at work. That is, rather than taking a kind of delight in the certainty of the earth, working instead for the absolute removal, the independence from tradition, from religion, from our parents, from the certain world, from the kind of foundation works that emplace us. And instead, the sense in this last 100 years of stripping away those ties and earning a kind of a void, almost the most beautiful enabling atheism or a modern emptiness as another kind of project, as trying to achieve a kind of independence, is such a very striking thing in the existentialist movement. And architecture, again, if you will accept that kind of characterization as having some of the qualities of the 20th century, then architecture has a rather different project again. And we might think of the generations of self-enclosed systems, of terraria or bubbles or places that take care of themselves. Perhaps the epitome of architecture in the 20th century would be that of a spaceship, or perhaps Expo 67's Man in His World by Buckminster Fuller, the lovely kind of self-enclosed sphere. This kind of project and the preceding project are both ones that depend on very particular conceptions of the world. And I feel very distant from both of them, I must say, because when I stand on this ground, and when I stand on the world, I find myself inhabiting a kind of a trembling membrane which is neither absolutely certain, nor certainly is it void, but rather the kind of slightly convulsive, trembling sense of concern, of exchange, of synthesis with the surface of the earth today, produces a very different response than either of those two historical movements that I've tried to characterize. And it would be very tempting to speak immediately about sustainability, as we all must, as an obligation. And as a teacher of architecture, I find myself, in one way, speaking about trying to close down, to make as tight a jacket as I possibly can, to make my own footprint and the footprints of the built environment as closed and tight and light as possible. And of course, this kind of language, which is at work, perhaps, especially at work in the last 10 years, is an absolutely urgent one. I mean, let me declare my allegiance with trying to reduce carbon consumption as much as possible. And yet, at the same time, this kind of project of trying to reduce and close as a response to what befalls us strikes me as a kind of a hair shirt architecture, or a kind of a reduction that only gets at 10 or 20% efficiencies and does not provide the kind of transformation that could really be a substantial offering in the sense of where the environment is at right now and what could really be possible. That kind of reduction relates to a very curious kind of assumption in architecture about what is perfect, the kind of eternally best, optimal architecture in the world. And if I was standing sharing these thoughts with you 50 years ago, I'm almost sure that I would speak about a perfect architecture as being a sphere. Buckminster Fuller, the great American engineer, would have been teaching me about this sphere, and he would have been saying it has the maximum enclosed territory, it has the minimum envelope. Envelopes are expensive. It is fantastically good. It's optimal to make this kind of perfect alignment and disposition of materials to make ourselves as clear and as bounded as possible. When I think about this kind of Platonic language, the language of reduction to minimum forms of spheres and cubes and crystals, then I think also that I am looking at forms that are very strangely machines for reducing relationships, because after all, mathematically, you cannot have less interaction with an outside environment than you can with a sphere. A sphere is the definition of the minimum surface for a given mass. And so there's a very curious kind of value system, I think, embedded in this very long tradition of looking at minimal, pure surfaces, which in fact is about polarizing relationships. You are either with us or you're with the terrorists. It's a kind of a fantastic form if you care about making something as strong and definite and pure as possible and having as little to do with the atmosphere as possible. The argument that I want to make to you and the work that I'm sharing is based on perhaps the alternative, the opposite language, which would be that of diffusive form rather than reductive form. In a diffusive form, we are seeking the maximum amount of relationship with the environment as opposed to the minimum. And nature knows this kind of form very well when we look at snowflakes or dandelions or lettuce or corals, for example. It's full of value judgments as well. I mean, it's very curious to see how diffusive forms tend to be thought of as grotesque, weak, the latest Rococo, perhaps, the Rococo, disgusting in its excess, compared to the very strong and obviously male and clean, effective world of a sphere. These thoughts then are searching for, rather than the kind of oppositional relationships that I've just been showing you, a kind of a mutual relationship where there are multiple boundaries, where there is an expanded physiology, and where individuals are bundles rather than individual figures. And perhaps this could be captured by thinking about how an amoeba behaves and what an amoeba is. As an early young science student, trying to be a clever science student anyway, I would have just drawn the edge of this kind of figure And I might have hatched in using just even color the interior cytoplasm. I might have given a tone to the exterior. But as we look closer to this kind of remarkable kind of figure, we can see that not only is it an extraordinary bundle of many, many grains and aggregates inside, as each of us are, but also that there are hormonal clouds being injected outside the line, the meniscus of its figure. And there's an exchange of pulling, a chemical osmosis, which is as much about the milieu pulling as it is about this little agent seeking and driving. And so this kind of extraordinary oscillation, the ambivalence between the milieu and the figure, becomes a kind of delicious model, a rather delirious model for a body of work. Let me show you 3 projects rather briefly to share how these kind of ideas have been developing. The first project is staged on the Atlantic coast, much like the kind of terrain that I was just speaking about in the abstract. And the project was to generate a geotextile. That is, we cleared a farmer's field of scrap alder as a work exchange, and we spun a very gentle meniscus, a layer using the simplest of structures, a tripod field with a triaxial grid rising around over it, in order to make a gentle meniscus that would shelter gathering growth. And it stood up for several years and served to generate a thickness in which turf started to accumulate, small animals nested, and it started very slowly to erode. More generations of work used active systems, such as organic power in this endothelium work, which was installed in Los Angeles a few years ago. Organic power, these were our vinegar cells using copper and aluminum electrodes. It's very similar to making lemon clocks or potato batteries, if any of you have made those as a child. And this work takes together many chains of bladders, generating 5 milliamps apiece, pathetically little amounts of power, collected in capacitance chips, just enough to generate tiny little bleats of electricity about every 5 minutes every 5 minutes in cycle from each node. And each of those little packets of current are attached to cell phone vibrating motors, which take an absolutely minimal current. They're arranged on stalks, which are chained to lever action feet, which, like porcupine quills, dig into the earth. And so if you can picture this entire geotextile then very, very slowly burrowing in the most kind of pathetic, poignantly weak kind of motion, a forlorn sense of trying to generate its own fundament and its own fertility. It's clothed also with yeast spores and with cellulose filters that burst out and fill the space, making a kind of an earth surface machine, or a thickness that would very, very slowly die over the course of the exhibit as the power fades. In more recent work, quite symphonic layers using structure and mechanism and more investment in distributed computation, along with early generations of protocell chemistry, that is synthetic cells which are being harbored in incubators within this work, are starting to work together in order to make more of a sense of a breathing, viscous, diffusive realm which would make a future architecture. In this work, you first come in, and the work is extremely quiet. You see basket-like structures, ghost-like, radically lightweight columns, and overhead hyperbolic canopies as a basic flexible structure. And then you see layers of thickness, of quite fertile bladders and gland-like secretions clothing the surfaces. There are arrays of space sensors that are studied all through the environment, and so it tracks your motion, and so very gentle responses, just the smallest twitches and flutterings happen as you come up to individual nodes. And so the overwhelming sense in this work is not one of a kind of an expansion of power where a robot is doing my duty or satisfying me, but rather there's an incremental kind of resonance of a relationship that starts to emerge, a kind of a tangible breathing which is radically diffuse. As you go further, the work becomes much more saturated, and after individual responses, such as a pebble which rolls out in waves in a quiet realm within a pool, then more and more ripples will happen as more people interact, and then the work can become quite turbulent and starts to be the combination of a multitude chorus-like cacophony, but all framed within the quietest of individual gestures. The principal mechanisms that are used are shape memory alloys. I mean, a lovely material which works with contraction and just gives back a very small amount of kinetic effect, and so we work to amplify that using leverages. Fitted out alongside that is the protocell environment, and I'll show that in a minute. But you can see the general sense of a whole web of intimate touches and small rippling actions, both in kinetic response, in acoustic response of twittering and vibrating and rustling. This is a small section which just explains some of the investment in the overall textile, because the work is quite resolutely physical. That is, it's based in a sense of flexible materials which are not durable, not particularly strong. Rather, they're conceived to be able to resonate and to tremble and to harvest the actions from the outside environment. And perhaps you can think of that as a kind of a structural extimacy, if you'll go with that term. They use a basic tetrahedral structure, very efficient, a fundamentally efficient space packing system drawn from nature, and then fitted out in the corrugated diagrid, which is the diagonally oriented overlapping systems which make this the textiles themselves, are series of mechanisms which allow the thing to flex and move. We also use air, as you can see in this example. In the clip that I'm going to show right now, you can just see some of the organizations of the elements in order to get to know it a little bit more in terms of its component systems. Hyperbolic canopy as a basic framework, column works, suspended filters which have convective air in plumes rising through them, and then each one of those layers is organized as individual elements which are chained together in communication system, which pass signals in the most primitive of ways, using near neighbor and far neighbor and global reaction systems. And then those different layers are combined all together in order to have cross-linking behaviors as well. And so this is using a basic subsumption system, the idea of individual reflexes embedded in local centers, as well as having global reactive systems. Here you can see one of the configurations where a space sensor sends up signals, and then a helical chain, a kind of a wave of convection will rise around it. Let me just emphasize a couple of the layers. One of the layers is the hyperbolic meshwork, and this is a very simple kind of construction of multiple tetrahedral elements made of opposing chevron forms, which clip together and then swell and bifurcate by adding stitches and by collecting the forces. It makes an overall tensile system into which there are local compressive elements which hold shape and which allow the overall system to be coordinated. So we could call it a tensegrity system, that is where you have a continuous tensile structure, but with local compression struts, local stiff struts floating in it. And that's very similar to natural organisms. We are tensegrity systems, or arguably. Here you can see some of the individual chevron shapes which we use, and these are multiplied by the hundreds of thousands now. We put quite a lot of work into snap fit, which is using very thin impact-resistant polymers, and then tapering them and configuring them so that cracks can't start, so that we resist as much as we can having sharp corners, and we try to blend out forces so that we can have quite substantial amounts of flex. In a snap fit, a jaw will deflect temporarily and then will snap back in, and so we can achieve then long tensile strands by virtue of the elements fitting together. These are also deeply tessellated. That is, they're designed for absolutely minimal material construction, so that one cut makes two things as much as possible. Alongside the structural systems, there is a sense of a design equation at work in which, rather than making something durable and clear, the attempt is to make something as reactive and as potent as possible, and that usually involves many, many cycles of design in which things are drawn out right to the very edge of their ability to span. And when you design at states far from equilibrium, you get very interesting behaviors. You get lovely kind of turbulences and resonances, as one small perturbation results in internal dynamics as well as exchanges of force shedding. Alongside that kind of physical manipulation of force, the sense of deliberate fragility, comes an almost emotional sense of tectonics, of making joints in which, rather than something simply fitting silently and dutifully, there's a sense of an agenda of desire or of repulsion that seems to be emerging quite consistently in the work, in which something clutches or resists or has a hunger or has a penetration. And this terrain of a charged kind of milieu is one that I have a great hope for in becoming more conversant for. It's the kind of language of kinetics that a dancer would know very, very well. But in architecture, the language is still rather fresh. A last layer that I'd like to share with you is the incubating quasi-metabolic systems that are layered through this environment now. And if you think of a breathing wall of the future, or perhaps a roof made of a multitude of cells, and if you imagine that processing environmental materials, for example, capturing carbon, translating that into harmless carbonate like a chalk or a limestone, or working for transpiration, then I hope you'll maybe have a sense of the motivation of making an architecture which could have a metabolism or multiple metabolisms built into it. In this case, we have a couple of systems, one which is generating skins, and another which is capturing carbon and translating it into carbonates. And here's an example of a skin-generating system, which is a Traub cell. It was originally modeled by Moritz Traub, who was trying to emulate amoebas. And in this prototype cell, there's a copper sulfate crystal and a potassium hexacyanoferrate outer solution. Copper is being deposited in a felt, which is then being pumped in osmosis, making this kind of blooming sticky felt that continually grows through the cycling. And we have this going outside the glass flask environment that's currently situated throughout this diffusive film that I'm sharing. And here we can see, thickened by alginate, a kind of a strand which is very slowly growing by the interaction, again, of the potassium ferric cyanide and the copper sulfate. And we'll just watch a strand developed in a series of rather convulsive little looping gestures here. There is no claim for this to be an industrial process or for it to be efficient, but the ability for chemicals to work together and to work in autocatalytic loops is really very heartening, and we do want very much to be able to have this kind of strand forming system making a kind of a clothing for the building systems in the future. And perhaps if we combine that with a kind of benign chemistry, such as one which is capturing carbon, then we can say that this is a useful skin-forming system. So then we could have a vision, if we'll forgive the kind of viscous quality of it, of a building that can sneeze. That was a joke. The next, I'll just share a next generation of work that we're very, very hopeful about, which is a lovely collaboration with a really lovely French-Canadian filmmaker, Phillipe, and this is an extract from his work Aura of this past year, where he's working with radically sensitive stereothermal sensing. There's no natural light in this film. Rather, we're looking only at the internal quasi-light from the heat generated from these bodies, and also the traces that these bodies are leaving in the ground that we see here. And this sense of being able to work with the sense of multiple octaves of an anatomy and the exchanges that might be possible is tremendously motivating and encourages us to think of the kind of diffusive environments that we've been pursuing as being ones that could have a radically greater sensitivity in the next generation. And so perhaps that could be captured in this last image of this expiring amoeba. Perhaps a complement to the earlier one, where inevitably when I look at that earlier one, I look at a kind of an agency of a pioneering thing which is searching and acting, much like my own personality has been taught to act as an individual. This sense of looking not so much at the bounded figure, but rather at a continuous mutual field of relationships in which the surroundings is every bit as active and pulls and receives and exchanges, might be one, I think, of kind of a fundamental analogy for a future architecture based on mutual relationships. And so I do hope that this term extimacy might be a useful one to refer to in the future. So I'll just sum up. I've spoken about a kind of historical fundamental relationship with a solid earth, the kind of delicious sense of being at home. And I've tried to talk about diffusive form as being a form language that might offer an extraordinary kind of potency of involvement for future work. I've talked about the kind of craft of working physically, working for resonance, working for deliberate fragility and potency, and perhaps pursuing an emotional tectonic and perhaps an active metabolism as a way of renewing architecture. And this then is currently being pursued in collaboration as a kind of a symphonic work, which might, I hope, produce some contributions to possibilities for future architecture. Thank you.
Thank you very much for all your interesting contributions. Lo que acabamos de escuchar esta tarde son aproximaciones muy distintas a la vida. Y quiero recordar allí una frase fundamental que planteó Christopher Langton en 1987, cuando se fundó y se celebró el primer taller en torno a la vida artificial. Decía que los que estamos investigando, trabajando en esos ámbitos de lo que él consideraba y definía como vida artificial, nos dedicamos a observar y estudiar la vida no como es, sino la vida como podía llegar a ser. Yo creo que esta tarde hemos visto una serie de ejemplos muy claras que nos introducen en esos nuevos campos de investigación de la vida como podía llegar a ser. Me imagino que esto a vosotros os podía plantear preguntas, dudas y un interés especial hacia uno u otro trabajo que se acaba de presentar esta tarde en este encuentro vida con 4 propuestas y 4 aproximaciones muy distintas para abordar el tema de la vida como podía llegar a ser. Por lo tanto, os paso la primera palabra a vosotros, ya que hemos hablado nosotros durante 2 horas, encantados de poder entrar en diálogo con vosotros. ¿Alguna pregunta, algún comentario? Que levante la mano. Tenemos aquí varios micrófonos dando vueltas, así que os animo a participar y preguntar. Okay, Matt, you wanted to say something? I just saw that you took the microphone.
No, it's just handed to me.
You have here the red button. Hello.
Yeah, I yeah, are there any questions? Somebody just walked up and handed me this. I didn't call for it, but I'd like to hear what you guys have to say. I mean, of course, my interest is in looking at corporations as metahumans, like as the real artificial life of our time is this sort of thing that we've created through the combined activities of our patterns of consumption, and I'm interested in how that acts against individuals, like at the expense of individuals, and I would think maybe that would touch on some themes in everybody's life, maybe, right? Like the world we're living in. We're living in strange times, definitely. Yeah.
I have a question to the
Sorry, take the microphone.
Yes, I have a question to the round. I mean, I didn't been here for all speeches of you, unfortunately, because I had another thing to do. But my question is, what is for you life? Is it more a product or is it more a process? And if it's a process, is the art in what you are doing or is the art in your output? I mean, it's a question I'm asking myself often, and I want to use this opportunity to have all of you here on stage.
Mm-hmm. I mean, I can just quickly say that yes, for me, life is definitely a process, and similarly, this is what I do is very process-based work. I mean, it's got conceptual foundations, but then it's very much a process-based activity in every way. I mean, the generating the works themselves is about a certain kind of story that's perhaps as interesting as anything that actually comes out of it, and then certainly the images that are forming are curiously enough very process-based. Even though when we see a DNA fingerprint, it looks as if it's always been static, but in fact it's always been moving. It's only shut off at a convenient moment to kind of give it the kind of air of instantaneity and imprint. So yes to I think yes to both your questions. And maybe lastly, I'll say what's been fascinating with me so much about this kind of imprint, this thing that's trying to look like an instant or like an imprint, is that DNA gel image is the most authoritative image we have. Right? The photograph no longer has any authority, right? Artists can mess with that. In the courtroom, videos, you can have a dozen police officers beating up on a black guy named Rodney King, and people will still say, well, maybe the video wasn't clear, or there's something a little muddy about all this. But the DNA fingerprint is still the thing that identifies one individual as being separate from billions, and thus the thing that can sort of cement guilt or innocence. And I guess that's why I'm fascinated by this process.
But there comes one question on related to what you just answered, because you mentioned that you're very interesting in the substance, in the materiality of DNA more than in the code.
Yes, yeah.
So related to this question, what would you answer? Because there is a paradox in your somehow in your considerations?
Maybe I don't see the paradox. I mean, one of the things that the last work particularly proclaims is that this metaphor of life as code is just a metaphor. Even the notion that DNA is a code kind of depends on your definition of what is. Because in fact it's a material substance that, like any material substance, can be abbreviated or indexed to a certain coded number, but it's not necessarily the same as code, or certainly not the way that we think about code in kind of a cybernetic, first order cybernetics. So does that help?
Okay.
Does it?
Okay.
Is this working? Yeah.
Yeah.
We've got these things too.
No, I guess
It's working again? Yeah. The question makes me very ambivalent, I must say, because I'm very tempted to subscribe to immediately to the process side. I mean, like that's the creed, isn't it? I mean, for the last 50 years or perhaps 100 years, we wouldn't be caught dead making monuments. I mean, of course, that we have to say that it's about process. We have to. It's an obligation. But when I see the flux, not as some kind of beautiful fertility, but rather the flux of Matthew's Home Depot kind of march of a global economics, then I must say that the sense of process as a beautiful thing takes me aback, and it makes me very hungry to have resistance and to step out and to hold something that's permanent and durable and resistive, and so that makes me very ambivalent about whether I agree with the work being about process at all. I mean, and similarly, I must say it makes me very ambivalent about the gathering that we are right now, because it's a very interesting kind of curated group that has been gathered. I mean, because we have such pictures of seeming resistance, crafting things that are almost revolting in what they offer, and then you have some flirtation with a kind of an activism of building the world, and I'll say mea culpa. I'm some of the claims that I'm offering are ones about future craft which will be used to make the world, right? I mean, that kind of geoengineering, in other words. Now, that would imply utterly different kinds of things, a kind of big division in the range that's just been shared here. Maybe I'll turn that into that ambivalence into perhaps the answer itself, an answer itself, by trying to capture my own little argument, because I started setting up closed, figural, optimal, recessive forms as kind of the enemy, the patriarchal enemy, and diffusive forms, maximum articulation, as being way better. But it would be very tempting to say that in artificial neo-living systems, mortality and resistance have tremendously fertile roles to play. And if I only work with diffusive forms, I just get masses of tangles which start to subside and start to get absolutely clotted through oversaturation. And so the act of cutting, of disjunction, of resistance, and therefore the world of mortality, of things that die as well as flow outward, becomes tremendously productive to speak about. And so I think that suggests that there's an oscillation between the states that you're describing, rather than taking a side. That would be an effective way to speak about a sense of purpose or mission.
Yeah.
Can I say something to that? But can you imagine that all life is being resetted like a computer. So it's death and then resetted. I can't imagine. So life is, if it's something that's going on, and once it stopped, and if there is no life all over, there will not be any life forever. So that's why I'm asking you, is life a process of or a product?
I was thinking something that Doug and I have been bouncing back and forth recently. We revisited the story of Phineas Gage. Do you guys know Phineas Gage? Maybe from like psychology class. He was a contractor working on the American Railroad, and he was really well liked by all of his colleagues, and he's like really charming and handsome. And one day in this freak sort of accident, this railroad, they use these rods to sort of compact gunpowder to blast away rock for the railroad, and this rod went through his cheek, scrambled a bit of his prefrontal cortex and out the top of his head, and they gathered him up, took him into town, but he ended up like living, they patched him up, and he survived this incident, this horrible trauma. But as time went on, like his doctors discovering that his personality had changed. He lost the ability to plan for the future. He became very impulsive. His life sort of fell apart. And when I was first introduced to him, it was through this injury we discovered the different divisions of the brain and how personality is a product of our hardware, right? Like process and hardware, But recently I've been more and more interested in him because the origin of corporations being declared people goes back to the Santa Clara Railroad sort of co-opting the U.S. government's in the emancipation of the slaves as an opportunity for corporations to be granted individual, to become humans in a sense, right? And so we were looking at this injury with Phineas Gage as not like just the story of the invention of an understanding of how our brains operate, but looking at this as a context between the birth of one organism and its effect on the previous generation of organisms. So the corporation affecting this human in a way that the human lost the ability to judge risk, to plan for the future, and eventually, cost him his friends, his wife, in his life. So my thought is definitely our sort of combined activities are creating some new form, right? It's like maybe some kind of corporate creaturehood. But the question is is that and I'm not talking about eToy, because you guys are maybe a good corporation, right? If there's, right? But I mean, but what's the impact of this corporation on of humans, right? Is it affecting our ability to judge risk, our ability to make decisions, or are we being sort of having our collective prefrontal cortex scrambled by their activities? Yeah. So just thinking about that, I think maybe yeah.
I suppose there's also this thing of like when we say life and death, of the person. Does this work? I think it's working, isn't it? I'm plugged in. I'm wired. Okay. I think I'm good. When we think of life and death of the person, that's also very kind of arbitrary. Like, what's the moment of death, right? Is it when the heart stops, or when the brain stops, or when the fingernails stop growing? What do you want to call the end of life? But then also it becomes even more complex, right? Anyways, when we think about the fact that we are, we're mostly not human anyways. We're mostly these combinations of, we have more bacterial cells than human cells in our bodies, and those things continue living for a while. And then when those things start to die, there's still microprocesses occurring within those cells, which very well might be considered alive. So this kind, in a way, that I think one of the things that happens in this more processual kind of understanding of life is also this notion that the simple kind of binary of, not only of where you define life beginning, at what level of complexity, but then also where you define it ending, I suppose becomes kind of intriguing.
¿Hay una pregunta más? Porque si no, hemos pasado ya de la hora. Y diría que muchas gracias a todos por haber participado en esta presentación. Gracias por vuestras presentaciones tan interesantes. Y gracias a vosotros por haber asistido a este encuentro con los artistas de vida 1999-2012. Gracias a todos y hasta la próxima.